Students, good morning. Today I am going to discuss about the inversion curve and the inversion temperature in Joule-Thomson expansion. Joule-Thomson expansion is employed for cooling and liquefying the gases. This Joule-Thomson expansion is employed for cooling and liquefying the gases. Point number 1. Adiabatic throttling technique is involved in this cooling and liquefaction of the gases. Adiabatic throttling technique. Adiabatic throttling is involved in this cooling and liquefying the gases. During cooling and liquefaction of gases, the enthalpy of gas remains constant. Enthalpy of gases remains constant. Hence, Joule-Thomson expansion is also known as isenthalpic expansion. Joule-Thomson coefficient is defined as rate of changes in temperature with respect to unit decrease in pressure at constant enthalpy. Rate of changes in temperature with respect to unit decrease in pressure at constant enthalpy. Joule-Thomson coefficient is defined as the rate of changes in temperature with respect to unit decrease in pressure at constant enthalpy. Right. This equation can be written like this: changes in temperature, that means final temperature minus initial temperature. Final temperature minus initial temperature divided by final pressure minus initial pressure. Clear? In general, most of the gases except hydrogen and helium, something like that, most of the gases shows a cooling effect. Cooling effect means final temperature is less than that of the initial temperature. Final temperature T2 is less than that of T1. So this is small value, this is high value. Small minus high is equal to minus value. Expansion means decrease in pressure. That means final pressure is less than that of the initial pressure. Final pressure is small value and initial pressure is high value. So small value minus high value is again negative. Negative divided by negative is equal to positive. So Joule-Thomson coefficient is positive, means it is cooling effect. Joule-Thomson coefficient, if it is positive value, it means it is a cooling effect. Joule-Thomson effect. Sometimes, however, it may be a negative value also. Negative value also means there will be an increase in temperature with respect to unit decrease in pressure. When temperature of gases goes to increase during the expansion, that means decrease in pressure, it will be the negative value. Negative means heating effect. To understand the cooling effect or heating effect, let us draw the pressure temperature diagram. Pressure temperature diagram. In x-axis, consider pressure P. Pressure P. P in x-axis, temperature T in y-axis. Let us consider the initial state of the gas is represented by point B. Point B represents the initial state of the gas. The initial state means compressed gas. Compressed gas is allowed to pass through a flow restricted device or a porous plug or a throttling valve or a partially opened valve, whatever it may be. Assume that a compressed gas is allowed to pass a porous plug. This information or experiment is already discussed in my previous videos. Okay, point B represents the initial state of the gas. Joule-Thomson expansion is a sudden expansion. Expansion takes place in a short span of time. So each and every moment will be important. At the initial stage or earlier stage, the gas experiences a increase in temperature. On decrease in pressure, the gas shows or experiences a increase in temperature. At one particular point, this increasing trend will be stopped. The point, call it as Q. So the increasing trend, increasing temperature, the temperature of gas increases in the region P to Q. Clear? At point B, there is a transition. Further decrease in pressure due to expansion causes us to decrease in temperature of the gas. Temperature of gas goes to decrease further expansion up to the point R. Up to the point R. Clear? Each and every point in this curve, slope of the points represents the Joule-Thomson coefficient. If you are considering this is the point, taking a slope, this gives dy by dx, dy difference in temperature, dx difference in pressure. So changes in temperature with respect to pressure is nothing but Joule-Thomson coefficient. This line is called as isenthalpic line. Isenthalpic line. Clear? Isenthalpic line. At one particular point, the slope of the curve or isenthalpic line is 0. The slope becomes 0. That means Joule-Thomson coefficient is 0. At Joule-Thomson coefficient is 0, the temperature at that point, the temperature is called as inversion temperature. Inversion temperature. T inverse. Inversion temperature means a temperature at which the Joule-Thomson coefficient becomes 0. For different kinds of gases, perform this experiment. Find the temperature where Joule-Thomson coefficient is 0. Join the points, the locus of points. The locus of points. This curve is called as inversion curve. This curve is called as inversion curve. Inversion curve is locus of points where Joule-Thomson coefficient becomes 0. Inversion curve, inversion temperature. This is maximum inversion temperature, T max. This is minimum inversion temperature. This point is minimum inversion temperature. This is maximum inversion temperature. So inversion curve, inversion temperature, isenthalpic curve. Everything was discussed. Clear? Right. The region Q to R is cooling effect. That means the region below the pressure Q, below the pressure Q is cooling effect. The region Q to P is the region of heating. Region of heating. So inversion curve is used to separate the region of cooling as well as region of heating. Clear? Inversion temperature much more useful to us to find the minimum temperature to provide the effective refrigeration, to provide the effective refrigeration. So inversion temperature, inversion curve, isenthalpic curve. This is a brief information on inversion curve, inversion temperature in Joule-Thomson expansion. Clear? Thank you.